Dear student, we'll see the next kind of example here. If f of z is analytic, show that bracket of dou square of dou x square plus dou square of dou y square into modulus of, this is the modulus of f of z whole square is equal to 4 times modulus of f dash of whole square. Fine. Solution. Let we know that f of z is given by u plus iv. Fine. And you remember, so u is, if it is Cartesian, u is a function of x and y, and v is also a function of x and y, so that's why we call it as analytic function. So take mod on both sides. Fine. So if you take mod on both sides, you know, remember, so it will become what here, so if you modulus, if you take, what happens, so mod of, it will become square root of this u square plus square root of what here, this v, only u and v have to take it, so square root of u square plus square root of v square if you take mod square, and take squaring on both side, so it will become modulus of f of z whole square is equal to, if you take square and root get cancelled, we'll left with what here, u square plus v square. So which I will consider as this u square plus v square, I will consider as what here, 5. Okay, next, so with the help of these small notations, we will rearrange our given question. So they have said what here, dou square upon dou x square plus dou square of dou y square of, so f of z of square, that is modulus of f of z of square. So I will write it as 5 because we have taken this here, just see here, mod of f of z of square we are considering as 5, so in place of this I will write it as 5 is equal to 4 times this mod of f dash of z whole square, that is, so I will rearrange. So if you multiply this 5 inside, it will become dou square 5 upon dou x square, which can be written as 5 xx, means double derivative of 5, because you multiply here, then you rearrange this notation, plus as it is, so dou square, this if you multiply, it will become dou square 5 upon dou y square, so this can be written as 5 of y is equal to this 4 as it is, so modulus square of f dash of z. Next, coming to the solution of this further, consider, so we have considered this 5 is nothing but what here, u square plus v square, so same thing I have taken here, 5 is what we have taken as u square plus v square, so this 5 will consider as what here, will differentiate this partial with respect to x. So if you differentiate this 5 with respect to x, means it will become 5 of x is equal to derivative of, because u and v both are function of x and y, so we cannot consider as here means constant function and all will not consider, because u and v both are functions of x and y, so therefore the partial derivative of u, what we have here, u square, will consider as 2 times u into with respect to x, means we'll write it as ux, plus similarly v is also function of x and y, so therefore partial derivative of v square will be 2 times v into vx, or we'll write it as 5 of x, take 2 common, so u into ux plus v into vx. So differentiating again this, what we got it here, so 5 of x, what we got it, will differentiate this again with respect to x partially, so 5 of x will become 5 of xx, it will become 5 of xx, so therefore, so this 2 will keep as it is, so for these two will apply product formula, so u will keep as it is, ux with respect to x will become uxx, plus will keep u as it, ux as it is, so with respect to u, with respect to x will become ux, will get here 2 ux. Okay, just see here, if I write here, so this is nothing but product of ux into ux, so therefore because one ux we are keeping as it is, we are differentiating this u with respect to x, so this will become ux into ux will become ux square, plus, so we'll apply product formula for this, keep v as it is, partial derivative of vx with respect to x is vxx, plus then again again will keep one vx, you keep as it is here, and partial derivative of v with respect to x will become what here vx. This vx and another this vx both will become vx square. So together will give as equation number 1. So similarly the same we can write as with respect to y also. So we'll interchange as, because here phi is a is a symmetric function, so that's why. So we can write in how we have taken for phi of xx, similarly we can write it as phi of yy. So that is 2 times u of yy plus, instead of u x square we'll write u y square, plus v into v x y, plus instead of v x square we'll write v y square, and we'll give as equation number 2. See, now we'll add this equation 1 and 2 and we'll see what we'll get it. So adding 1 and 2, so phi of left hand side of 1 plus left hand side of 2 is equal to 2 times, and while adding I have taken common also. So 2 is completely out, because in equation 1 as well as we have 2 and 2 also. So while adding I have taken common as u into uxx plus uyy plus v into vxx plus vyy plus ux square plus uy square plus uy square plus vy square will give equation number 3 for this. Next, so this we got because of what here, adding equation 1 and 2 and simplifying we'll get this result. Then since we know that, so phi z f of z is nothing but what here, u plus iv, you know that one, which is also we called as w, you remember, okay, is an analytic. U and v are harmonic, fine. Hence if they are harmonic, so we know the condition that uxx plus uyy is 0 and vxx plus vyy is equal to 0. This process we have seen in the derivative of harmonic for Cartesian form. We also have CR equation. So what is CR equation? Will convert all y function in terms of x here. So here uy is nothing but minus vx, and ux is nothing but vy. So therefore what we have, the equation number 3 here will replace this all, will replace in equation number 3 this all results. Okay, so just see, go back to the equation number 3. Our equation number 3 is what here, left hand side phi xx, what we have is, just see the same thing, phi xx plus phi yy is equal to this 2 as it is, bracket u into bracket of uxx plus uyy according to the first harmonic condition we can make it as 0, plus second v times vxx into vyy, but vxx into vyy is nothing but according to harmony it is also 0, so we'll write v into 0 plus this ux square as it is, vx square as it is, fine. Next coming to the uy square, but what is uy? Ui is nothing but minus times vx, but here what we have, uy square, so therefore if you square it we'll get here minus times vx will become minus times vx square, because we have uy square here. So therefore uy square can be written as what here, vx square, and similarly this uy square can be written as what here, ux square, according to the these two conditions. So on simplification, u into 0 0, this also will become 0, what left, 2 as it is, ux square 2 times this ux, and this ux will become 2 times ux, and this vx square and this vx square will become 2 times vx square. So therefore what happens here, so this 2 will take it common, and if you outside, if you bring it, it will become 4. So 4 times ux square plus vx square, and will give as equation number 4. But we know that to show the analytic, we know the result that f dash of z is equal to ux plus I times vx, and if you take a mod for this, so mod of f dash of z is equal to square root of this ux square plus this what we have vx square. So on squaring for this, so we will get here mod of f dash of z whole square is equal to square and root get cancel, ux plus vx will get. Now continue, so we got this result as ux plus vx. Now use this result again in equation number 4. So left hand side of equation 4 is phi xx plus phi of yy equal to 4 times it is what here, So this result, so I'm using this uxx plus uyy, I'm replacing here as modulus of f dash of z of whole square. I'm replacing here. So we know that, so phi of x can be written as what here, phi square dou square phi upon dou x square, plus this phi y can be written as what here, dou square phi upon dou y square, and right hand side as it is. So you can take this phi as a common outside, it will become dou square upon dou x square plus dou square upon dou y square of phi is equal to 4 times f modulus of f dash z of whole square. Or this can be written as, so dou square phi dou square upon dou x square plus dou square upon dou y square, close the bracket. This phi, you can just see in the beginning we have considered phi as what here, modulus square of f of z, which is equal to right hand side as it is. So this is a required result for the given problem. Next problem, if f of z is regular function of z, show that bracket dou by dou x of modulus of f of z whole square plus bracket of dou by dou y of modulus of f of z bracket whole square is equal to modulus of f dash of z whole square. Okay, we'll see how to solve this solution. Again same process. So solution, let f of z is equal to u plus iv regular. Regular means analytic. We know the one more meaning of analytic is nothing but we call it is regular function. Now take mod on both side. So mod of f of z is nothing but, so square root of u square square root of v square, and this I will consider as what here, phi. Now we have to prove that, so according to you, this notation will rearrange our given above a question. So I will take it as, because we have taken mod of f of z will consider as phi, so therefore you can rewrite this one as dou by dou x of this I will consider as what here, phi. So instead of f of modulus of f of z can be written as phi, and this whole square as it is, plus dou phi by dou y whole square. We have again, I have changed this as f mod of f of z as phi, equal to this right hand side as it is. Now phi is nothing but what here, square root of, because what we have taken, this phi is nothing but square root of u square plus v square. So squaring on both sides, so what happened, phi square is equal to, on squaring root will cancel, u square plus v square left. Now this phi square is equal to u square plus v square will differentiate with respect to x now. Okay, so we'll get on with respect to x, what we'll get here. So phi, we have phi square there, so it will become 2 times phi into phi x is equal to, so we have ux square, so derivative of ux square will be what here, 2 times u into ux, plus we have vx square, derivative of vx square will be 2 times v into vx. So on dividing 2 on both sides, we'll get this phi into phi x is equal to u into ux plus v into vx, give equation number 1. Because of this a symmetric function, so similarly with respect to y we can write it as directly as phi into phi y is equal to u into uy plus v into vy, and give equation number 2. Next just concentrate here. So I have taken 1 square, equation 1 square plus equation 2 square, so 1 square left hand side. So what happens, if you square the left hand side of 1, it will become phi into phi x whole square, plus right hand side of 2 will be, you have to square it, that is phi into phi y of whole square is equal to right hand side of equation 1 square, means you need to square this both. So what happened, u into ux plus v into vx whole square plus u into uy plus v into vy whole square of equation number 2. So left hand side we have added with squaring, right hand side we have added with squaring. So on simplification, so this you open it, this will become phi square phi x whole square plus phi square plus phi y square. is equal to, so this you need to apply a plus b whole square formula. Here also you need to apply a plus b whole square formula. So simplification will get this completely. Fine. Next you just see here, by using CR equation. So what is CR equation? Uy is equal to minus Vx and Vy is equal to Ux. So this will apply in what here? RHS here. So we will keep U square as it is, Ux square plus V square into Vx square plus 2 times Uv into Ux into Vx plus U square. But this Uy, what is uy? Minus times vx, but we have here uy square. So for this we'll write it, instead of writing minus vx square, it will become what? Because of squaring, minus will remove, will vanish, so it will become vx square plus we have here v as it is. Vy will use it as a CR equation and make it as ux, so it will become ux square because we have vy square, that's why it will become ux square plus 2 times uv. This uy is replaced by minus vx and this vy is going to replace by ux. Rearrange completely, so we'll get, so among this you take from this and this, you take u square common, we'll get it as ux square plus vx square, and among these two you take v square common, we'll get ux square plus vx square. And if you simplify these two, because of this negative sign, this will become minus and this cancel each other. So we from left hand side, you take 5 square common, so we'll get 5x square plus 5y square is equal to, so here because of the factorization you can consider as factorization, so here both the brackets are same, you take common, so what left here? U square plus v square. But we know that 5 square is nothing but u square plus v square, so you do one thing, so here what we have, 5 square left hand side as it is equal to, this is nothing but what here? 5 square, replace it ux square plus vx of square as it is. Next here 5 square and this 5 square cancels, we have left with 5x square plus 5y square is equal to ux square plus uy square. Now so we have left and give equation number 3 for this. But we know that f dash of z is given by ux plus I times vx. Take mod on both sides, it will become mod of f dash of z is equal to square root of ux square plus vx square, or on squaring both sides we'll get mod phi dash of z square is equal to root will vanish because of squaring ux square plus vx square. So equation 3 will use this result in equation 3, means I will replace ux square plus vx square as modulus square of phi dash of x in equation number 3. So therefore left hand side as it is, phi x square plus phi y square is equal to modulus of phi dash z square. So this can be written as dou square phi upon dou x square plus dou square phi upon dou y square is equal to right hand side as it is. Or but we know that phi is nothing but modulus of f of z, so apply this result here. This phi will be replaced by mod of f of z, this phi is also replaced by mod of f of z here, so we'll get the required result. Thank you. So next we'll continue for the next new example. If phi of x comma y is a differentiable function and f of z is given by u of function of xy plus I times v is a function of xy is a regular function, show that dou phi upon dou x square plus dou phi upon dou y whole square plus bracket of dou phi upon dou u square plus dou phi upon dou v whole square close the bracket into modulus of f dash z of square. Now let us treat phi as a composite function by regarding phi to be a function of u and v, and we know that u and v are function of x and y, remember, by chain rule. So we'll write a chain rule for dou phi by dou x So dou phi by dou x, by using chain rule we can write it as dou phi upon dou u into dou u by dou x plus dou phi by dou v into dou v by dou x. Similarly, we can write a chain rule for dou phi by dou y also. So dou phi by dou u into dou u by dou y plus dou phi by dou u and dou v into dou v by dou y. So you know that what I am telling, phi is a function of what here, u and v, but u and v is a function of what here, x and y. So therefore dou phi by dou x we need to find, and dou phi by dou y we need to find here. Fine. Next, this dou phi by dou x can be written as, in short, as phi x. This dou phi by dou u can be written as phi of u into dou u by dou x, in short you can written as ux, plus dou phi by dou v can be written as phi v into dou v by dou x can be written as vx. Similarly, for second chain rule we can write it as, and we'll make it as equation number 1 and 2 here. So again 1 square plus 2 square will get, so adding left hand side with right hand side. So first we have to make it square. So left hand side is only one term, so phi x square, and left hand side of equation 2 is phi y square. But here when you square for the right hand side, we have both sum, so it will become both two terms whole square, two terms whole square of equation 1, two terms of equation 2 whole square. So here we need to apply a plus b whole square formula, here also a plus b whole square formula, and we'll get this simplification. Now again, so all uy and vy or whatever results are, the y term will convert in terms of x. So whatever expansion we got here after a plus b whole square formula and a plus b whole square formula for both the terms, and this is simplification. By CR equation we know that uy is nothing but minus vx and vy is nothing but ux. So right hand side will apply that one. So the first, this phi u of square into ux square, will keep these as it is, first a plus b whole square expansion, plus second will change it as, here see here this term. So this term you see, so phi square u as it is, instead of uy square will write it as what here, vx square, plus phi v square will keep as it is, instead of uy square will make it as what here, ux square, minus, because actually it is plus, 2 times phi u phi v as it is, but uy is nothing but minus vx, that minus I have multiplied, I have written here as minus, plus into minus is minus, and we'll write ux, and this vy is nothing but what here, ux. So you have to rearrange, and both will cancel and simplify. Next, so in simplification, so you consider these two, so phi u square you take it common among this, ux square plus vx square. Similarly among these two you take phi v square common, you will get ux square plus vx square. So simplify again, so both brackets are same, so you take it as a factorization for this, simplify and give equation number 3. And as we know that again f dash of z is nothing but us plus I times vx, so take mod on both side, so it will become mod of f dash of z square is nothing but ux square plus vx square. So this result you apply in equation number 3 and we'll get a final this result.